Hello everyone, myself Dr. Triparna Saha, and from today onward we'll be starting a new playlist in the YouTube channel. The playlist name will be Pattern Recognition. Today is the first lecture of that lecture series. Today we are going to introduce ourselves to the pattern recognition. So let's start today's lecture. For not only for this particular lecture but all the lectures throughout this particular playlist, we are going to follow this particular book as well as some portions of the slides are from the Google search results as well. You can particularly follow this book of pattern recognition. It's a very good book. Anyone tries to learn pattern recognition can go through this book. So, while learning any subject, we need to know what is the subject is all about. So, the first topic of this lecture is what is pattern recognition. A pattern is an object, process or event that can be given a name. A pattern class is a set of patterns sharing common attributes and usually originating from the same source. During recognition, or commonly known as classification, given objects are assigned to prescribed classes. A classifier is a machine which performs classification. So, that is all about what is pattern recognition, what is classification. Now, what are the applications of this pattern recognition? There are numerous applications of pattern recognition. One of them are machine vision, where image classification and tagging, that is face detection and video recognition, are use cases of machine recognition. So what is that? Suppose you have given one's face. From that face, you are trying to generate a biometric gate opening system where a gate to a office will be opened when when employees of that particular office only visited. Now, in earlier cases or nowadays also many offices have certain identity cards, and if the employees show the identity card, then the security personnel opens the gate for them. But suppose we are trying to make one automatic system where there will be no security guard and there can be some biometric information can be taken from the employees of the office, and based on the biometric classification, the gates will be opened only for the employees of the office. Now for that you can have in the biometric information can be in the form of fingerprint as well as that can be in the form of our faces. Based on our faces, each of our face has certain distinct features. That is how much our eye opening is that, what is the contour of our lip. Based on that, different features or different parameters can be identified from each of our face. Based on that, face can be detected, and based on the detected face, it can be classified whether that particular person is one employee of that office or not. If he found that he works there, he or she works there, then gate will be opened for that person. So that is one example of pattern recognition where it has one application in the domain of machine vision. Another can be character recognition. So what is character recognition? Suppose certain text has been written in a plain paper. It can be different alphabets, different numbering systems, or whatever be the thing. Based on the written text, you need to convert that written text, that is handwritten text. Handwritten text is there in a plain paper, and that handwritten text you need to convert into the soft copy. So suppose in the handwritten text you can see that each of the person's writing style of one particular alphabet, suppose A, is different than the style of writing of that particular letter A for the other person. Different persons write one particular alphabet in his own style. That is, so there will be a different variations in writing the alphabet. Based on the different variations, you need to find out the parameters of one particular alphabet again. That is the features. From the features, you need to classify whether it belongs to the alphabet category or the numbering category. After classification, it can find out that which alphabet it is. Then it will find out this alphabet A. Then it is in the capital, that is capital A is there. So that is the character recognition. That is from handwritten text to make it a soft copy of it. It can be one example of pattern recognition as well. Another example of pattern recognition, that is computer aided diagnosis. What is that? You can be given one image of an X-ray. Now, one normal person X-ray and another person where there is a bone fracture has been there, that can be identified from the X-ray. Now, for what a doctor does, a doctor sees the X-ray of the fractured person, the person who has got the fractured bone, and identifies that he has got fractured bone in this particular area. That is, this particular bone is now fractured. That the one doctor can do. That is, you need a manpower for that. Doctor is also a person, so you need a manual help. But now you want to do it in an automatic way. So how we can do it in an automatic way? So automatically computer will going to identify. Computer itself is going to identify that whether there is a fractured bone is there or not. If there is a fractured bone, then which bone it is. So that is the computer aided diagnosis, one example, that is identifying the fractured bone from the X-ray. Okay, another can be from the EEG signals. For this particular application, I have already certain videos in my YouTube channel. You can follow those videos where I have given the detailed application of how one EEG signal, that is the classification of EEG signal, can give us the mental state of a person. That videos were there, so that you can follow to understand the classification of EEG signal. Now another can be, suppose ECG signal, one person has one problem with the heart, so that is checking the heartbeat, that is checking the ECG signals. By signal processing, computer can automatically detect that which type of heart problem the person has. That is another example of computer aided diagnosis. Another example can be speech recognition. So what is the speech recognition? If you earlier know me, then by just listening to the voice of me, you can identify that yes, this person is Dr. Sriparna Saha. Now if I know you, by listening to your speech, I can identify you. That is, each of our speech has certain features or certain parameters. By that we can identify the other person. It can be the pitch, or it can be the how the other person throw, or how the other person takes gaps while speaking. That is, different types of attributes can be identified from one person, that signal processing of the speech from other persons, the person can be identified. So that is the speech recognition, another application of pattern recognition. So there are numerous applications of pattern recognition. You can go through other pattern recognition applications by searching the internet as well. Now in this pattern recognition, there are two terms, those are very much there can be sometimes ambiguity due to understanding of the two terms. One term is classification, another term is clustering. So let us understand what are the difference between classification and clustering. You must understand that classification and clustering are the two different types of pattern recognition process. The processes are completely different than each other. So first, talk about the classification. So, classification is the process of learning a method for predicting the instance class from pre-labeled or classified instances. This is also known as supervised learning. Suppose you have two class data, class A and class B, and the attributes calculated from each of the class instances belonging to class A and class B has been mapped along a 2D surface where the x-axis the value is the x1 attribute and the y-axis the values are for the x2 attribute. Now the classes has been mapped in the 2D space. Now based on the classes of the mapped values of the class instance values, you need to classify another unknown instance. And here during this classification process, the class labels for each of the instance values will be known to you. That you already knew that this particular instance value belongs to class A. This particular instance value belongs to class A. This particular instance value belongs to class B. That is, the pre-labeled class information is already known to you. That is, it's something of supervised learning. That is, there will be a supervision. Based on that, prior knowledge is given to you. This is the classification process. Now, let's talk about the clustering. Clustering is the process. I'm extremely sorry, it will be clustering. Let me change it. Yes. So, clustering is the process of finding grouping of instances given unlabeled instances. It is also known as unsupervised learning. So, what is that? You have the values of the instance values, and from that earlier you have calculated some attributes and the values have been plotted in the 2D surface that you are doing. But while doing the grouping process, you do not know the labeling of each of the instance. You don't know that is this particular instance belongs to which cluster. That information is unknown to you. That is, the instances given to you are unlabeled. That is, you don't know their class levels. But without knowing the class levels, you are just going to group the data into two groups. One will be cluster A, another will be cluster B. So, this is the clustering process. And this difference will be much more clearer to you when we will go to the later videos where C-means clustering, fuzzy clustering, each will be explained to you. So, this is the classification versus clustering. That is, for the classification, prior information of the class levels will be given to you, and for the clustering, no prior information will be given to you. Now, this is all about how different types of learning in pattern recognition can be possible. So, what is the pattern classification system? It comprises of mainly three steps: pre-processing, feature extraction, and classification. Pre-processing is the process where we need to remove redundant information from the background. You got some data. From the data, you need to remove certain unimportant information. Take the example of speech recognition. So, in the speech recognition, what we are trying to recognize, we need to recognize which person it is. Now, the person is suppose speaking while there are some horn sounds are coming from the background. That horn information, that is some horn from some certain cars that are in the background. That information you have got in your speech signals while the person is speaking. But that horn sound is going to give you some useful information? No, right? But that is going to disturb, and those are the noise to you. So you need to remove the horn sound from the background. So that is the removing of redundant information. That is, if we can process the speech signals and remove the horn sound from the person, that is a signal from where the person is speaking. So that is the pre-processing. Now another step is feature extraction. That we have already talked about so many things about features. So features are basically the attributes or the parameters by which we can easily identify that which class it is, or each of the class can be segregated by the other class. For example, suppose you need to classify between mango and apple. So what can be the features here? Suppose the features are color. So if that is the feature for mango, the color will be suppose yellow. If it's a ripe mango, the color size of the outer layer of the skin of the mango will be in yellowish tone. But for the apple, it will be in the reddish tone. So one of the attributes by which you can differentiate between the two classes of apples and mangoes are the color of the outer skin of that fruit. That is the feature. Now the feature extraction, that is to reduce the data by measuring certain features. Next step is classification. That is to divide the feature space into decision region. That is, you need to classify the classes based on the features extracted. That is, from mango and apples you have classified, that you have extracted some features. Now based on the features you need to classify those. So that is to divide the feature space into decision regions. That is the classification. Now if we want to draw the design cycle of the pattern recognition, it will mainly have 5 different stages. First is the data collection. So what is the data collection? You need to acquire a huge amount of data, or a sufficient amount of data to be very much precise, to successfully classify. So what can be that? Suppose you are doing the speech recognition, so you need to have sufficient amount of data for each of the person. That is the data collection. Excuse me. So that is the data collection. Now, from the collected data of the speech signals from each of the person, you need to extract certain parameters or features. That is the feature extraction. After the feature extraction stage, you need to design a particular model in the pattern recognition. While will be in the later videos, you can see that is different models are there, different algorithms are there. Based on the algorithm, you need to select your proper algorithm which will be going to the best choice for your particular task of pattern recognition. That is, model should be selected properly. Then based on the model, you need to train the classifier. After the classifier is trained, you need to evaluate the performance of the classifier. That is, what is the error rate, suppose, how much precise your system is. Those are the different classifier parameters that you need to evaluate. And this will be the total design cycle of the pattern recognition process. So just have the examples of that. So pre-processing, we have already discussed these stages in the concept of speech recognition. Let us take this from the machine vision, that another application of that is in the image processing domain. Just have the examples of each of the particular stages of the pattern recognition. So one is the pre-processing. So pre-processing is what? Suppose you have one image. So this is your original image. From this original image, you need to identify that which posture it is. So we are talking about the application of posture recognition. So for this original image, while you need to identify the posture of the person, so what you need to do? You need to remove the redundant information, that is the background information. So you need to segment out the redundant information from the image. and after removing the redundant information from the image, what you get a segmented image. Here we have done the skin color segmentation. So there was step of data collection. We have talked about that we need to collect sufficient amount of data. Why this sufficient amount of data? Without having the sufficient amount of data, this segmentation process cannot be done properly. For the segmentation process, you need to give certain threshold values in the RGB range. Now, if you do not have the proper amount of data, you cannot specifically justify the threshold values of the RGB and the range. So, to justify or to get the proper amount of threshold values or to have the proper segmentation process, you need a sufficient amount of data. After that, what we need to do? We need to do the feature extraction. What could be the features over here? That is the distance between two palms. This could be one feature. Distance between 2 feet. This could be another feature. Distance between right palm and feet. That could be another feature. And so way on, we can calculate different other features. That is different other attributes by which this particular class of posture can be segregated from the other class of postures. And the last is the classification. For the classification, we need to define the classes. That is, among which number of classes you are going to classify your posture. What could be your classes? Your classes can be 3 different, that is sitting, standing and dancing. Between 3 different classes, suppose you need to classify your unknown image. So after the model training and the unknown image, you have already from the unknown image you have calculated the features. Now you have already trained the model. Now from that you need to classify which type of posture it is. So which posture it will be? It will be a dancing posture based on the features we have calculated and the model has been trained. So if your system can properly classify these unknown image into dancing posture, that is the correct result. So your accuracy performance result of your classification will goes up. If your classifier failed to classify this particular posture into the dancing posture class, then your classifier performance will decrease. So this is how the performance evaluation of classifier is done. So this is the design cycle of pattern recognition. So this is all about for the first class of the pattern recognition. Thank you everyone for watching this particular video and happy studying.